services and applications, and really provides a border guard kind of function. So any kind of communication stream going in or out of that SOA service provider is intercepted by that policy enforcement point, and the policy is enacted upon that stream of communications. That's a very, very powerful concept because it actually decouples the whole idea of policy from your applications. The reason that's important is really policy is something that changes a lot. Policy is something that you actually need to be easily edited. You need to be able to make modifications to it in response to changing business need. If you burn policy into your application, so in other words, if you implement it through actual code, whether it's in Java or C# or Ruby or what have you, you suddenly lose the agility. Whereas if you pull it out into a separate entity, an intermediary that actually acts on streams of communications, that is actually that separate policy enforcement point, all of a sudden you have a purpose-built device that can actually start to authenticate streams, authorize them, deal with SLAs, do threat detection, load balance across a number of different systems, and the list goes on and on and on. So you can start to see the policy enforcement point as this very, very rich gateway concept that you can get a tremendous amount of benefit. Now, what does this have to do with governance? Quite a bit, it turns out. When you talk to people about governance, it really means a lot of things. Governance is not technology. That's the number one thing you've got to remember. Really, governance is a whole broad view of the people, the process, the policy around how you actually manage your applications. Now, the most important part of that, in terms of technology, the most important technological enabler of governance really is this idea of the policy enforcement point. It is that border guard. It is that thing that gates access to your back-end systems, that monitors, that keeps a record of all the transactions that have been happening. That is the foundation of governance, runtime governance that is actually acting day-to-day on every single transaction. That's the key piece of technology that you need to bring into your networks, that you need to really bring into your SOA, but also your cloud networks, to actually give yourself a good, technological foundation for governance. Now, of course, the technology isn't everything. You still need that process behind it. You still need to train your people in acting on this the right way. And you still need sort of a deterministic approach to how you're looking at the big picture of security and monitoring. But of course, the technology is an enabler of that. And that's a key point that we like to talk about a lot here at Layer 7. If I look at the key elements, really, of what governance is about and what runtime governance is about, really can be broken down into three key things. One is the enforcement of policy, ensuring that basically what you want to get done gets done in every single transaction. There's a real compliance part of this, of course, because you may have, let's say, to have to conform to HIPAA regulations. If, let's say, you're in the United States and you're doing work in healthcare or something like that, you have very, very specific compliance issues in terms of things like patient privacy. And devices for runtime governance, like Layer 7 Secure Span Gateways that I'm showing you right here, can be engines to enforce those rules. In other words, they're there for the technological basis of really your compliance program. So that is a key part of the whole governance equation. The other important piece of it is monitoring and reporting. You need to know exactly what's going on in your entire network. And if you have a device, like a secure span gateway that plugs into your network like this, that's acting as a border guard, gating access to those back-end services, it can see everything. It can actually start to act on those transactions going back and forth and essentially characterize them and record them, audit them, and send all sorts of data out to monitoring and reporting engines, which can actually give you the big picture of what's going on. How many times a second is your stock quote service being hit? Is it 30,000 transactions a second? If so, maybe you have to add more capacity to your back end. These are the kinds of questions and answers that you can actually start to enact with these devices if they sit in the middle. The third part of it really is publication. So if you're taking one of these devices, if it's sitting as a border guard in the middle, essentially guarding those SOA service providers, it actually has to publish a description of what that provider is and what the kinds of security declarations, security expectations that transaction has. This is a really, really important part of the whole equation. That publication of not just the API description, not just, say, the WSDL if you're doing SOAP messaging, but also the policy associated with that. All of these components, whether it's the WSDL, whether it's the other kinds of metadata and assets that are actually a part of the whole equation in terms of doing real SOA, all of these can be controlled within the internal repositories in Secure Span gateways. And it turns out, within the gateway structure itself, we've got all of the other workflow, management, versioning, rollback, everything that you need around that whole concept of essentially a registry and a repository. But the difference is then it's not actually something that's separate. It's not teased out, and put into some, centralized location. It's actually where that data needs to be in the network, where it can be acted on a day-to-day basis. And it's a very, very powerful concept. So the thing about policy is that at Layer 7 we take a big P approach to policy. And what I mean by that is, for us, policy is a lot more than the classic image of authentication and authorization. Policy is actually everything you can do to that stream of communications between a sender and a receiver. So it begins, of course, with authentication and authorization, because that's very important to a lot of secure SOA messaging applications. But policy can also be the place where you articulate, let's say, an SLA. You might want to say something like, well, when I exceed 10,000 transactions a second, what I want to do is buffer them at the gateway, because I know that my back-end service can't deal with more than 10,000 transactions a second. So I want, like, when that 10,001 comes in, in a 1-second time window, I might want to buffer it. I might want to hold on to it for a little while until the data storm passes and then let it through. So in other words, you're starting to do traffic shaping on the back end that's all enacted through policy. The logical place to articulate that is the same place you articulate your security requirements, the same place you articulate your monitoring requirements. What about things like orchestration and routing? I might want to do something like, say, when a message comes in, I'll authenticate the sender. I'll authorize the sender, make sure they're allowed to get access to the service. But then I'll look at what their role is, or maybe what attributes are associated with them. Let's say they're in the gold group, in other words, one of my most favored customers. I might want to make a decision on the fly which sends their transaction to my fastest servers, because I have an SLA with them that says I will absolutely guarantee you, sub-millisecond response times. So if I can do that, then I can actually start to enact other kinds of business logic around my policy. So you can see that policy suddenly becomes quite a bit more sophisticated, which is why I like to say policy is sort of a big P thing. We think policy is where you articulate, enforce, and express all of these different kinds of rules at Layer 7. And with Secure Span gateways, of course, we give you that technology. We give you the ability to actually build up these very, very rich policies or rule sets in a very simple but also very deterministic manner. For us, policy in a lot of ways is like an algorithm. You can actually use it to string together little components that actually express these kinds of rules and that solve problems, not just in security, but also in SLA, and routing, and monitoring, and orchestration, all of these different components. And they can all be strung together in a very, very simple graphical algorithm. And what you see down here on the lower left, or sorry, the lower right, excuse me, is an example of what policy can look like. This is the Layer 7 Secure Span console, which is where you build policy. And up there on in the console itself, on the upper right, is the actual policy algorithm. Okay, that's where we actually take assertions, and there are probably over 100 of these, pretty much out of the box. String them together in an algorithm, not unlike a graphical scripting language. And because of that flexibility, it's the perfect platform for solving problems in terms of integration. Because it turns out that a lot of the issues that are coming up again and again these days in SOA, in SOAP messaging, in XML messaging, in REST, are the kinds of problems which really are dealing with the client sees things one way, the server sees things another way. And in particular, a lot of them are around differing ideas and security models. We can actually start to deal with those impedance mismatches, to tie up those loose ends, and deal with them on the fly and expressed again through policy on Secure Span gateways.